No, I'll just do the integration here. I think I'm okay. All right. So the p is a constant, right? This p is simply a constant, so I can just pull it out. So that will simply give you 1 over C max minus C min. Then you have alpha over C out minus delta C, integral of that. What is that? Natural log. You have alpha log of C max minus delta C over C min minus delta C. Right? Okay?
Is alpha always a constant?
We are assuming that, yeah. As I said, if there's any weakness, a real weakness to this problem, it's in that expression alpha over that. I can give you a more accurate expression, but it just involves a little bit more mathematics. So plus beta, you can integrate that. So what will the integral of that? You can either do it by term, or you can do the whole thing one shot. Right?
C max squared minus C min squared over 2.
So it will be C max
Squared.
minus delta C minus CS squared
Oh, yeah.
over 2 minus,
I think they're all
that's it, 0, right?
They're
Yeah.
individually squared.
Yeah.
Huh?
C out, it would be
You don't
C
have to
max.
do it, you can do it individually squared and then you can kind of combine terms again. It all depends on how whether you integrate this whole thing together or one shot, one by one. You see what I'm saying?
Oh, okay.
You can just redefine this variable. You can just call this to be y, which is y squared over 2. Of course, you have to change the limits. So minus, at the lower limit, C out is just this, so that term just gives you 0. Right?
Is there supposed to be a bracket after the Ln term?
No, it's going to go at the very end. Because
It's log of
you
a
pull out
minus b, so it's
probability.
a log of a divided by log of b, right? And then yeah, so probability is common, so I take it out. So I'm just doing both integrations in one shot. Right? So that's it. Sorry?
One more bracket.
There's one more bracket.
One more bracket on the right.
One more.
Why is there one more bracket? Is it
Right,
easier?
Because you have 2 brackets leading and then one.
Oh, okay.
Because math.
Actually, I did not need one of the brackets. Actually, I don't need this. Because I don't need this. Right?
Fancy.
You can see how I did the integration. I mean, I could have done it term by term, but then you'll be left with, I don't know, too many terms. Right? Yeah? Yeah. Yeah, so they're just constant values. Yeah, of course they're different units. Right? Everybody sees. I think I did this correctly, right? Did I mess it up or no? Sometimes I mess up things.
I thought you said P.
C out minus delta C minus CS whole square over 2. C max. I think it's okay. Well, I can do it slowly if you want. So it will become C out. So C out squared over 2, right? So that will be C max squared over 2 minus CS
That's what I thought it was the
plus delta C squared over 2. Right? And then you have plus or minus delta C plus CS times C max minus CS minus delta C. Right? Yeah.
How can you pull the probability out of both if the integrals are not necessarily the same? Like C min and CS plus delta C. How do we know the integral of the probability function from CS plus delta C to C max is equal to 1?
Well, we don't. This is already taken out. So this is P is already taken out because it's a constant. We don't know. Right?
Okay, yeah.
Make sense?
Normally, would it not be a constant? Because if you had like a Gaussian distribution,
Yeah, yeah. In that case, you just have to do the integration. Okay, so yeah, you could also do the integration this way, right? So that's just a lot of work. Now we have to kind of combine that. So I can show you how this works out to be the same. So you can see if you take delta C plus Cs times Cs plus delta C, you can see both are the same. So you get delta C plus Cs whole square with a plus sign. That will knock this off, right? And so you'll be left with a plus here, right? And this will go away. And then if you do this twice of that, you can multiply this by 2. So you can see this will become C max minus Cs minus delta C whole square. Right, you can see the same result, yeah.
Just a little bit confused. So up there with the beta C out minus delta C minus CS, that's our cost function, right?
Yeah.
CS equals delta C, or negative delta C plus C out. If you plug CS into there, don't you get C out minus C out?
Sorry, I don't understand.
So this CS
So
expression,
C out we don't know, that's the whole problem. We don't know C out.
C out minus delta C equals CS. This
No,
expression-
I said that would be the case if you knew exactly that, so you could
Oh.
implement that, but we don't. Unfortunately, we don't have that choice,
Okay.
right? Okay, so anyway, is it okay if I just integrate like this, or you can, whichever way you prefer. You can see both ways you get the same answer. Yes? Fine? Can I move on? Okay, so I'm going to erase this. All right, so now we are in good shape because now we have the total cost and everything is known there except delta C. So now how do you optimize something where everything is known except one unknown? Okay, you take the derivative, set it equal to 0. Why? What's the basis for that? And how do you know it's a maximum or minimum?
You test the values.
How? Why? What is the basis for all these statements?
Calculus.
Okay. All right, so I'm going to very quickly prove to you that indeed that guarantees you a maximum or a minimum, okay? So to do that, we invoke Taylor series. So let's say your function f, okay? And let's say you're expanding this function around, so you're writing this expression around, let's say f of x plus h. You're expanding a function around the x, and h is the distance you have gone away from it. Okay? Everybody knows Taylor series, right? So this is simply equal to f of x plus h f prime plus h squared over 2 factorial f double prime plus so on and so forth, right? Okay. Now let's see what does it mean for f to have a maximum at at x. So a function, so to write it that way, what we do is we write it in this way. We say f of x plus h minus f of x equals to h f prime plus h squared over 2 f double prime, right? So now, what does it mean? So to do that, let's just say draw a function. So let's just say f, and let's say it has a maxima at x, right? And h is this distance. So if you want a maxima at x, what does it mean? That if you go away from this point, what happens to the value of the function? It decreases in both directions, right? Shh. That means irrespective of the magnitude and sign of h, the value of the function should be lower. So what does that mean? That this difference must be negative, irrespective of the sign of h. Does it make sense? This thing, this must be negative. Now the first term, is that positive or negative? It will depend upon the sign of h, f prime and h, but the point is, it will not change sign. It will be, it will change sign. If it's negative for positive h, it will become positive for negative h, right? So this term, if this term is non-zero, then this this function cannot have a maxima at f of x. Does it make sense?
If x is if
Huh?
yeah, if h is what? If h is negative, is f negative?
Now the point is this function, for f to have a maxima at x, this difference must be negative on either side of x. Make sense? Just like on a mountain. If you're on a mountain, I don't want to invoke mountain because mountain is x and y and z. But nonetheless, imagine you have a one-dimensional mountain. If you are at the top, there's a very interesting book. What is that book? Sorry? It's a book about everything is in 2 dimensions.
The art of the deal.
No. I'll try to figure out, I'll try to remember what the book is. It's a very interesting book. It's a book of what life would be like in 2 dimensions.
Flatland.
Oh,
It's a flatland, that's right, flatland. It's a very interesting book. So if you are on a mountain top in 2D, if you move away, both directions, the height goes down, right? So that means this difference must be negative. But this term, you can see, doesn't have that property. If h is positive or negative, the sign of those two will be different. One is positive, the other has to be negative. So for this to be a maxima at x, what has to be true about this term? It must be 0. Right? Does it make sense? So that's why f prime must be 0. Okay, that's where that requirement comes from. Yeah.
So this is probably stupid, but for higher terms, when you have h cubed, h can still be positive or negative.
Well, yes, we will talk about that term. We can certainly write that